Right, so in this session we'll complete the rest of the topics. So we discussed until binary in the last session. So next topic is characters. Uh, so give me 1 minute.
Chapter 5 due date is this week.
This week labs.
Yeah.
Chapter 5 labs. So characters. The char type. This is a small topic, but it helps a ton with input parsing, validation, character, working with text. So character versus string. So the char is one single character. Think of A7, or it could be a question mark. That's character. String is a sequence of characters, like hello. Yeah, but Java shows the difference with the quotes. We have character with single quotes, and double quotes for the string. So if you're storing one letter, use char. If it's words or any length of text, use string. We have Unicode and escapes. So Unicode, Java char uses Unicode under the hood. That just means it can represent many languages and symbols, not just basic ASCII. So you don't need to memorize codes, but know that each character char has a numeric code point behind it. We have few escape sequence. This is for new line. You move to the next line, it will move to the next line. So we have, this is for tab, this is for single quote character, double slash, single quote, and double slash is these are handy when you need to print text with special formatting. So because a char maps to a number, you can do a simple math. For example, a plus 1 gets you the next code value, which corresponds to b. So this is useful for simple shifts like moving to the next letter. Keep it small, don't build a cipher here, but it's good to know it exists. And character helper methods, these are super useful. Java gives you the character class with the static methods to check what kind of char you're looking at. Character dot is digit. Let me open the notepad. Okay, so character dot is digit, let's say C. Basically it checks, is it 0 to 9, and we have is letter. It basically checks, is it a letter. And we have white space. It checks for spaces, tabs, new lines. And we have uppercase and lowercase, which basically converts to converts the case. So these are perfect when you're parsing input and want to allow only letters or filter out digits or count spaces. So some of the things to remember, things to avoid is mixing up char and string. Remember, single quotes is a char, double quotes is a string. So if a method wants a char, give it a char, and use equals with string. We'll cover this more in the string section, but use dot equals to compare strings by content, and equals only checks if it's the same object. With char, equals is fine because it's a primitive. With string, use dot equals. So how you'll use this when you're practicing, like for validating input, did the user type a digit? That's when you use the character dot is digit. And for normalizing text, making everything uppercase before comparing, that's when you use character dot to uppercase. And for formatting, simple formatting like adding a new line at the end, that's when you use this one, print /n. So use char for single characters, string for text. Know a few escape sequences, they will be very helpful. And use character methods to check and transform characters. And don't confuse equals for string content. Save that thought for the next topic. So yeah, that's about characters. Next we have strings. So probably one of the most common things you'll work with in Java is strings. So strings are how you represent text, whether it's names, messages, or even input from the user. First thing to know is strings are immutable. That means once you create a string, it never actually changes. So when you call methods like replace or to uppercase, you don't change the original string, you get back a new string. This can trip people up at first, but if you want the updated value, you have to assign it to a variable. We have some common operations. We have length, basically how many characters are in the string. It counts how many characters are in the string. We have substring, begin and end, which pulls out part of the string. Remember, the end index is exclusive, so substring 0,3 gives you the characters at the position 0, 1 and 2. And we have indexOf, so which finds the first position of something inside the string, like a space or a letter. We have equals and equals ignore case, which compares two strings by their content. Replace old and new, it swaps out parts of the text. An example, let's look at the example. Let's say string name is equal to hello world, and name dot length. This gives us 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's so there are 11 characters, including the space. And so next we have, I think, substring. So substring 0,5, it will give you hello. You'll notice 5 is not included. Yeah, 1, 2, 3, 4. So, and next we have this gives 11. Now next we have indexOf. Let's say world. This gives us 6. The word starts at 6, the position 6. So and next we have equals. Let's say hello world. So this gives us false because the Java cares about the case, and here we have lowercase, but at the input we have uppercase. And we have equals ignore case. Let's give the same. So this gives us true because we told it to ignore case. Name dot last one is replace. Let's replace world with Java. This gives us hello Java. But the original name is still hello world unless we reassign it. So yeah, that's a quick simple example. Some of the things to avoid is using equals to compare strings. Equals checks if two variables point to the same object, not if the text is the same. So always use dot equals or equals ignore case for comparisons. And forgetting that substrings and index is exclusive, so beginners often expect it to include both ends. For example, substring 0,5 gives you characters 0 through 4, not 0 through 5. Sorry, so here it's the index starts with 0, 1, 2, 3, 4 and 5. So the sixth is the word. It starts with, yeah, so I forgot to mention the index starts with 0, not 1. I don't know why I thought, but yeah, it starts with 0. So and so strings are everywhere in your code, so getting comfortable with them now will save you a ton of frustration later. So remember, strings are immutable. So use the right methods for comparisons and watch your indexes carefully when using substring. Yeah, I suggest after, like, when you get time this week, try these, like printing out substring, compare two strings with equals with or dot equals, and try to replace and see how the original string doesn't change unless you assign it back. So those little experiments will make it stick. And as always, if something is confusing, reach out. I'm happy to help. So that's about strings. Next one is integer overflow. So we'll talk about integer overflow. This sounds fancy, but it's really about what happens when a number goes past what a type can hold. In Java, int is 32-bit. Range is about minus 2.1 billion to plus 2.1 billion. That's not the exact number, but yeah, 2.1. So long is 64-bit, range is huge, about this much. Java gives you constant, so you don't have to memorize. Integer dot max value and integer dot min value is for integer, and long is the same, long dot max value, long dot min value. That gives you the range. So what does overflow look like? If you take an int at its max and add 1, it wraps around to the negative side, so no crash, no warning, so just a wrong answer. That can be hard to spot. Try this in your IDE when you get time. Print integer dot max value and add 1 and print the result. You'll see it jump to a large negative number. That's overflow in action. Think of cars odometer rolling over, so that's a good example. So when overflow bytes in real work, where overflow bytes in real work is accumulating scores, counters, or milliseconds in a loop that runs a long time, and multiplying large numbers like pixels, array sizes, and casting a long down to an int without thinking. If it doesn't fit, it silently wraps. So there are a few ways to detecting and avoiding overflow. So simple few approaches are: use bigger type before the operation. So if you think results may not fit in int, go to long first. Like for example, will a multiplied by b fit in int? If you're not sure, do the math as long. That's one way. And use exact check methods. Math.add exact, math.multiply exact, math.subtract exact for int and long. These throw an arithmetic exception if overflow happens. So super helpful during development to catch problems early. And there are few pre-check against bounds, which is manual guard. Before adding a plus b, you can check if b is greater than 0, and ensure a is less than or equal to integer dot math value minus b. That's one way. It's a little wordy, but it's deterministic and fast. And if values can be truly huge, consider big integer. It's slower and more advanced, but it never overflows. For this course, just know it exists. Some of the things to avoid is assuming Java throws on overflow. It doesn't. For int long, you get wraparound. And ignore edge cases. Code works for normal inputs, then blows up at extremes. And casting after the fact. So doing big math in int, then casting to long later doesn't undo overflow. So prompt before the operation. Know your type ranges. Promote. I don't know why I say promote to long, or use math.exact before doing big math. Don't expect Java to warn you. Overflow is silent unless you check for it. That's it for integer overflow. Next we have numeric data types. So we're going to zoom out and look at the numeric data types in Java, and more importantly, how to choose the right one. So picking the right type makes your code faster, safer, and less buggy. So Java gives us 6 main numeric primitives. We have byte, which is 8-bit, very small whole number. We have short, it's 16-bit, small whole numbers. int, which is, as you know, 32-bit, the default whole number type. We have long, which is 64-bit, big whole numbers, and we have float, which is 32-bit floating point and decimals to with less precision. We have a double, which is 64-bit floating point and decimals with more precision, the default for decimals. So think of this way, use integer int for most counters, array indexes, scores, any whole number that won't exceed 2.1 billion. Use long when the numbers can be big, like timestamps, file sizes, large counters. Use double for everyday decimals, like averages, distances, physics-ish calculations. Use float only if you have specific reason, like memory constraints or a library that expects float. Otherwise, stick with double. Let's quickly frame ranges and memory. Ballpark idea is enough for now. So int is about, as I mentioned, minus 2.1 billion to positive 2.1 billion. Long is huge, and float is 7 decimal digits of precision. Double 15 to 16 decimal digits of precision. So if you're calculating distance like 1, 2, 3, 4, 5.6789, double will keep it clean. Float might drop detail after 7 digits. So the difference between float and double and when to choose what. So double is safe default for decimals, more precision, fewer surprises. Float is smaller and faster in some context, but it has less precision. If you need to store millions of values, like in graphics buffers, you're working with an API that specifically requires float, go for it. Otherwise, stick with double. Some of the things to avoid is using float without a f suffix. So in Java, a decimal like 1.23 is a double by default. If you really want a float, write 1.23f. Without the f, Java will compile about assigning a double to a float without a cast. So, and another thing is assuming double is exact for money. So doubles are great for physics and averages, but not precise currency math, because doubles are binary floating point. Certain decimal values can't be represented exactly, like 0.1. For money, you generally use integer cents, which stores like $10.99 as 1099 cents using int and long. So, or decimal type like big decimal, which is more advanced. Even if you are using long cents, you still format for display like $10.99. That's presentation, but yeah. So choosing the types. So long counters, sizes, indexes, that's when you use int. Timestamps, IDs, big counters, that's when you use long. Physics, calculations with decimals, that's when you use double. Huge arrays where memory matters, or APIs that demand it, that's when you use float with f suffix. Money, financial, you store as integer cents, or use big decimal if you need exact math. I think that's about that's about numeric data types. The last topic for today is random numbers. So let's talk about something fun, which is random numbers in Java. You'll use these all the time in games, simulations, testing, or even just to shuffle a playlist. So there are two main ways to get random numbers to Java in Java. So we have Math.random and the random class. Math.random is the quick and simple one. It gives a double between 0.0, which is inclusive, 1.2 and 1.0, which is exclusive. That means it never actually hit 1. For example, let's say double r is equal to Math.random so now that's not so it basically checks between 0.0 and so now that's not very useful by itself, so we'll usually scale it. So if you want a random double between a and b, that's when you use a plus math.random say b minus a. So if a is equal to 5 and b is equal to 10, this gives you something between 5 and 10, inclusive and exclusive. So random class on the other side gives you more control. You can create a random object and then call methods like next int, next double, next boolean, like random, let's say random rand is equal to new random, and let's assign int n is equal to rand dot next int 6. So this gives 0 to 5, and if you want like 1 to 6 instead, just shift it to like something like int roll is equal to rand dot next int let's say 6 plus 1. This gives us 1 to 6. I should be capital, and random numbers in computers aren't truly random. They are generated using algorithms. So by default, Java seeds the generated with the system clock, so you'll get different results each time. So but if you give random a seed yourself, like a new random 42, you'll always get the same sequence back. That's useful for testing or debugging when you want repeatable results. So with math.random, the lower bound is always included, so the upper bound is always excluded. So with next int n, the result is between 0 and n. So next int 6 gives you 0 to 5, not 1 to 6. So you have to add 1 if you want it to start with at 1. And some things to avoid is forgetting the upper bound is exclusive and reseeding every call. So don't create a new random object inside a loop with the same seed. It will just give the same result again and again. Create a one random and reuse it. And so use math.random for quick doubles. Use random for more control integers or repeatable results with the seed. Always remember the bounds. Lower bound is in and upper bound is out. So yeah, try these with your Zybooks and IDE. You'll get a better understanding. That's all for this session.